All right, welcome to section 2.1, graphs of basic functions and relations in symmetry. Okay, so continuous, an informal definition on continuous. Basically, a function is continuous on its domain on the graph if it can be drawn without lifting the pencil from paper. For example, this one, I can draw it without having to lift my pencil. However, this one, in order to get to the next part, I have to lift up my pencil and draw it again. So the first one is continuous. The second one is not considered continuous. Now, another definition, increasing, decreasing, and constant functions. So to decide whether a function is increasing, decreasing, or constant on an interval, you're going to ask yourself, what does the graph do as x goes from left to right? So again, we're reading horizontally like you read on a book, and then you're trying to figure out what the graph does. So increasing, the graph rises from left to right. So if I look at my little example here, where is it increasing? From left to right. Again, reading from left to right. It increases on this interval right there. Now decreasing is when the graph falls from left to right. So reading from left to right, where does it decrease? Well, this direction. And then it's constant. Where is it constant? When it remains the same from left to right, and that's going to be this interval right here. So usually, again, you're reading left to right with the x values, and you're looking how the function falls or rises, and then you're answering in the x values. So for example 1, list the intervals where the function is increasing, decreasing, and then constant. So let's just go ahead and draw on a graph where that happens. Well, this is the constant part right there. It's not changing. And then it decreases in this little piece right there. And then it increases in this piece right here. Again, remember, reading from left to right. So for my increasing, let's see, it increases from the interval right here up until, that arrow means positive infinity. So what x values are they? Well, it is from 0 to positive infinity. Again, includes all of these possible x values. Even as the y's are going up, the x's are still going outwards towards positive infinity. So that's 0 to infinity. Now decreasing. That's just this small little blip right here from -1 to 0. And then for constant. Again, from reading left to right, we start in the negative x values and then we continue and approach all the way to -1, but we don't include -1. So negative infinity to -1, and that's it. We don't include it. All right, and that is increasing, right here again, the decreasing in red, that small interval, and then the constant interval right there. So let's take a look at some basic graphs of the parent functions and what their increasing and decreasing are. So for the constant function, the domain is going to be from -infinity to positive infinity. And remember, domain are my x values. The range is going to just be b, because that's the only y value we use, is that range of b, and the constant, -infinity to positive infinity. And then it is continuous on its domain. For the identity function, very similar, except my range is also -infinity to positive infinity, domain and increasing as well, and then continuous on its domain. So I'm just reading over these quickly, but again, spend some time focusing on these and memorizing this from your textbook as well as from the video. So we have the squared function, which is also the parabola. It is continuous on the domain, and then the domain -infinity to positive infinity. Range, in this case, is from the minimum and onward up. Decreasing from -infinity to positive infinity, and then increasing from 0 to infinity. The cube function. Domain, again, -infinity to positive infinity. Range, also -infinity to positive infinity. Those arrowheads pretty much mean infinity whenever you see an arrowhead. Also, it is increasing the entire way. It never decreases. And then continuous on its domain, again, because if I were to draw it, I wouldn't have to lift my pencil up. Now the square root function. This one is a little different. It's just a small blip here and only one arrowhead. So again, just going to positive infinity on the domain and range, and we do include 0 for both domain and range. And then it's only increasing, it's not decreasing when we read from left to right, and then again, continuous on its domain. For the cube root function, let's see. Again, domain negative infinity to positive infinity. Range still negative infinity from positive infinity. It is again increasing always. And then it's continuous on its domain. Absolute value function. So we have if it's just x, x is going to be greater than 0. And if we have a negative x on the inside, x is less than 0. So let's see. Again, domain is continuous, negative infinity to positive infinity. For the range, however, we start at the 0, and then we continue up, positive infinity, negative infinity. It is only increasing from here to here, and then it is decreasing from here to here, and continuous on its domain. So again, those are just some examples of the basic parent graphs. If you have any questions on how to read domain or range, please email me and we can set up an office hour. So let's go ahead and move on to something called the symmetry of our graph. So the symmetry with respect to the y-axis, which again would be this, would be something called the even function. And we can test that, but if we input negative x, it will come out with the exact same function. Another thing is with respect to the origin right here, and that is going to be called the odd function. That is, if I input a negative x, I'll come out with the opposite of the original function. Again, this is how we test it. Both ways we test by inputting a negative x. The output is what determines if it's going to be an even function or if it's going to be an odd function. And then if we input it and nothing happens, that would be considered neither even or odd. So those do exist. And then something with symmetry with respect to the x-axis. We replace the y value with negative y, and it's going to result in the exact same equation. And the only function is f of x equals 0. So example 2. Graph the equation y, or x equals y squared by plotting points. So usually, for something squared, I like to have at least 5 points. So I'm going to go ahead and make a table of values. And let's see, it's easiest if we pick a y value and we can solve for x. I'm going to go ahead and pick a few negative values and a few positive values as well. And I always like to include 0. So plugging that in, I know that x is going to equal y squared. So if I square negative 2, what will I get? I'll get 4. If I square negative 1, I'll get 1. Again, x is whatever y is, but we just square it. Or you could also see right here, x is going to equal negative 2 squared, which is 4. Here, x equals negative 1 squared, which is 1. Again, all based on our original equation, right there. And then, x is going to equal 0 squared, which is, again, just 0. Then x equals 1 squared, which is just 1. And lastly, x is going to equal 2 squared, which is 4. Again, these are my coordinate points, so let's go ahead and plot these. The point 4, negative 2. Let's see, 4, negative 2 is right here. And then we're plotting the point negative 1, or 1, negative 1, right there. And the point 0, 0, right here. And then the point 1, 1. And then 4, 2. Okay, so if I were to graph this, that comes out looking like, a sideways facing parabola. And there we go. Again, so with parabolas, please go ahead and continue, or not continue, please graph 5 points for a parabola. For lines, I just require 3 points. So now let's go ahead and determine whether the function is going to be even, odd, or neither. And again, how do I do that? Well, again, the test is to plug in a negative x into my function. And then, depending on the outcome, we know if it's even, odd, or neither. So if, when we plug that in, we get just f of x right on back, then we know it's going to be an even function. Let me go ahead and highlight that. Oops, wrong color. That would be an even function. So if I plug in that negative x and I end up getting back the opposite of my original function, that would then be an odd function. If neither of these instances happen, so it's not the exact same function and it's not the exact opposite function, then we just say it is neither even nor odd. So let's go ahead and work on the first one. So for f of x, again, our test, what are we testing? We're just testing what happens when I plug in the opposite of x. So now this function that we have here is actually the constant function. It says no matter what you input, we're always going to end up with 0. So the answer is going to be 0. And again, 0 was my original function. My original function was f of x equals 0. So this stays the same. It's going to be an even function. So now, for f of x equals square root of x plus 1, what is that going to be? And again, for showing your work, you need to show me that you plug in the opposite of x when you're doing these problems. So that's going to be negative x, and then we're going to have that equal to negative x plus 1. Even if I fiddled around and brought out that negative, that's going to be x minus 1. And that isn't actually going to be anything. That is going to be neither. It neither looks like the original function, and it doesn't look like the opposite. So again, that was the original function. What would the opposite look like? The opposite would be the square root of x plus 1 with a minus sign on the outside. So again, it's neither. Let's look at C. Again, we're testing this out if it's even or odd. So to do that, I'm going to go plug in that negative x. And then let's see what we get. So that's going to be negative x minus 1 over negative x. I can simplify the double negative here. That'll be negative x plus 1 over x. So does that look like this or the opposite of it? And again, the opposite of it would be x minus 1 over x. So far it doesn't, but I'm going to go ahead and do that same trick of taking out that negative. So pulling out a negative 1, that'll be x minus 1 over x. Because again, if we distributed it in, we would get what we had above with the plus sign. What do you know? That looks like the opposite. That right there is the exact same as the opposite. So because it's the opposite of my original function, this is going to be an odd function. And you need to go ahead and show me that it's the opposite of the original function. Okay, so let's go ahead and try the next one. Feel free to pause the video and try this out by yourself and then check in with me with your answer. Again, plugging in the negative for the opposite of x. What will we get? F of negative x is going to equal, that'll be negative, here, interesting. Anything cubed, is that going to be a positive or a negative? It's still going to end up being a negative because when we cube something, we're multiplying it to itself twice. So while that might become a positive, there's still a negative. So positive times positive times the negative is going to be a negative. So my outcome's still going to be a negative. So that'll be negative x cubed. And then we have the double negative there. It's going to be positive x. So this is going to equal, those two we're going to multiply together and give me a positive. So that'll be x cubed plus x. Well, let's see. Again, I'm trying to figure out if it's the same or not. Right now, it definitely is not the same function, so I know it's not going to be even. If I were to take the opposite of my original function, again, this is my original function. Let me do some test work here. The opposite of that, what would it be? Well, multiplying in that negative, that's going to be x cubed plus x. Is that exactly what I have right here? It is. So I know that the opposite of my original function is what I got, which means this is going to be what kind of function? It's going to be an odd function. Yes. Okay, so let's go ahead and write that out. It's going to be an odd function. Just waiting on my pen here, just giving a mini glitch. There we go. Odd function. Because it is equal to the opposite of x cubed minus x. Let's take a look at the last two. Again, please practice trying to pause the video and trying these out by yourself and then checking in with me. So let's see, f of x is going to equal, and we want to replace the x with the opposite again. That's what we're doing to test. So plugging in the negative x, negative x, negative x, negative x. Now, whenever we take any negative item and we raise it to a positive power, it's always going to end up being a positive number. So that's just going to simplify out to x to the 6th power. Same for the 4th and same for the 2nd. So it'll be minus x to the 4th plus x squared. Oh, and what do you know? What does that look like? That looks like the exact same original problem. So because it comes out being the exact same function, this is going to be an even function. Awesome. Yes, good job. And lastly, let's take a look at this next one. Still same goal. We're just going to go ahead and plug in the opposite and see what we get. So plugging in opposite of x. Again, simplifying. So that's going to be negative 3 times x. That's going to be the absolute value of 3x. So is that the same or the exact opposite as the original one? Well, if I was to simplify this function, this would actually be the absolute value of negative 1 times the absolute value of 3x. And the absolute value of negative 1 is just 1. So this is really the absolute value of 3x. So these two are the exact same function. So that means this is going to end up being an even function. Alrighty, that is it for this video. If you have any questions, please email me and we can set up an office hour.